Today I am going to solve some problems on bridge rectifier. Problem number 1 from Millman and Halkias book. A full wave rectifier is supplied with AC voltage of 220 volts RMS through a transformer with a turns ratio of 10:1. The load resistance is 1 kilo ohm. Assuming the ideal diodes, find the DC voltage, calculate the RMS value of the output voltage and determine the ripple factor. So before solving this problem, we should understand what is RMS voltage. RMS voltage is the effective value of the AC voltage. It is the effective value of AC voltage. So what is effective value of AC voltage? It is equivalent to the DC voltage that produce the same amount of heating effect in a resistor. This is called as RMS voltage. The effective value of AC voltage is nothing but the DC voltage, equivalent DC voltage, which produce the same heating effect in the resistor is called as RMS voltage. In question, the RMS voltage given is 220 volts. And what is given? The transformer turns ratio is 1 kilo ohm. Here the RMS voltage is 220 volts, turns ratio is 10:1, load resistance is 1 kilo ohm, and it is assumed the ideal diode. So what is ideal diode? Ideal diode means it allows the current to flow freely in one direction. So the forward resistance of ideal diode is 0 ohm, and the reverse resistance of ideal diode is infinite, and there is no voltage drop across it when it is conducted. So when ideal diode conducts, there is no voltage drop. So unlike real diodes, which has typically drop of 0.7 volts for silicon, there is no voltage drop across it when it is conducting. This is the meaning of ideal diode. They have given the parameter ideal diode. Now let us find out the first parameter, that is find the secondary RMS voltage. Calculate the RMS voltage. So from this turns ratio, we will calculate the value. Turns ratio is defined as primary by secondary. Primary is given 10, secondary is 1. So the value of this is 10 by 1 is 10 only. Then V secondary is, the turns ratio is given by primary turns by secondary turns is equal to V primary voltage by V secondary voltage. So here V secondary is equal to, from this we will calculate V secondary of RMS voltage is equal to V primary into secondary turns by primary turns. From this I will calculate V secondary is equal to V primary into turns ratio, secondary turns ratio by primary turns ratio. V primary is given by 220 volts and secondary turns ratio is 10. Primary turns ratio is 1. So here secondary turns ratio is 1, primary turns ratio is 10. 0 and 0 cancel. Answer is 22 volts. So V secondary RMS is 220 by 10 is 22 volts. This is answer. And find the peak voltage at the secondary. So the peak voltage is given by Vrms into root 2. Vrms is question itself, just now we found out 22 volts into root 2. Root 2 is nothing but 1.414. Answer is 31.11 volts. And the next question is find the DC voltage. So VDC voltage is, so VDC in full wave bridge rectifier is 2 Vm by pi. So 2 divided by pi into Vm. 2 divided by pi is 0.636 into V peak, just now we calculated, it is 31.11 volts. So the answer for this is 19.8 volts. So VDC is 19.8 volts. Now we will calculate the RMS of the output voltage. Vrms is equal to Vm by root 2 for the bridge wave rectifier. So Vm is 31.11 volts, just now we calculated, and 1 by root 2 is 0.707. So 0.707 into 31.11 is 22 volts. And the last step is finding the ripple factor. Ripple factor is given by the formula square root of Vrms by Vdc whole square minus 1. Vrms, it is 22.0 volts, 22. And Vdc, in the previous step we calculated as 19.8 volts. That will substitute here, 19.8 volts whole square minus 1. So 22 by 19.8 whole square is 1.236 minus 1. So square root of this is square root of 0.236 is 0.486. So the DC voltage is 19.1 volts, RMS voltage is 22.0 volts, and ripple factor is 0.486. In question they asked to find out the DC output voltage. We got the DC output voltage is 19.8 volts, and in question they asked to calculate the RMS value of the output voltage. The RMS value of the output voltage is 22.0 volts, and the last parameter in the question is determine the ripple factor. The ripple factor we calculated 0.486.